Greetings, grade 12 teachers and grade 12 learners. My name is Tulani Mjigwa. I am the maths facilitator at the Maths and Science Infinity, which is also known as MSI. MSI is in collaboration with the Department of Education. We ensure that learners are improving in results for mathematics and physical sciences. Right, in this video for mathematics grade 12, we are giving you the strides for the revision as you are preparing for your trial examinations. You will be writing your second paper for mathematics on the 11th of September 2023. Right. As the ECDOE, Eastern Cape Department of Education, is busy making sure that we are improving in this academic year, we say all you need is to hold on to the learners that passed and push them. The 20%, those who are between 20% to 35%, we need to focus on that group as teachers to a minimum of 45 marks, which gives us the 30% pass mark in the second paper or in each paper. This should be achievable by separating the Amber learners and maybe your level 2 learners as well in a separate class and target certain minimum marks in each topic to revise. So it is emphasized and advisable that as teachers you do not revise everything with these learners. Just select some topics in which you will be able to use and target the minimum marks that these learners can obtain in achieving this minimum mark, which is 45 marks out of 150, because a learner at 45 marks out of 150 is considered as a learner who passed mathematics at 30%. So we say do not revise everything with them, for them or with them. Make sure that you give them stuff that they can use to achieve this minimum pass mark. Right, in this video, we will now be looking at the second paper, second mathematics paper. As you are now preparing to write maths paper 2 on the 11th of September 2023, I will give you now the strides on how to prepare, on how to make sure that you score the marks that will enable you to be considered as someone who has passed mathematics, or how, as a teacher, how are you going to deal with your learners? How are you going to teach your learners, prepare your learners for this maths paper 2? Right, let's first look at this structure of paper 2. Then we have topics in paper 2. The second paper, the second mathematics paper, has only 4 topics. It has only 4 topics. So we have statistics, analytical geometry, trigonometry, and the Euclidean geometry. So looking at the statistics, which consists of 20 marks. When they say plus or minus, it can be less by 3 marks, it can be more by 3 marks, but average is 20 marks. That is the weight of the paper. We say now, these learners, these low-hanging fruits that we are dealing with, we need to set targets that they must achieve so that these learners will be considered as learners who passed mathematics or the second paper. So In statistics, we say these learners must target a minimum of 10 marks under statistics. Then what do we do, or what is important, what are the key aspects in that? Learners must be able to choose correct formulae. Learners must be able to choose correct formulae from the data sheet in case of questions that require them to use the formulae or the formulas. There is analytical geometry. There is analytical geometry which weighs about 40 marks. Under this, we say to learners, achieve a minimum of 10 marks in this paper, in this question. And there are two questions under analytical geometry. The first question on analytical geometry, usually question 3, is based on the information that you have from grade 10 and grade 11. Your quadrilaterals, your triangles, or the polygons. So, it is that question. Then the second one involves the circle analytical geometry that has now been introduced in grade 12. Then, if we say as learners target that 10 marks, that a minimum of 10 marks, how are you going to do that? Or what are the key aspects that will help you to be able to achieve or to get that 10 marks? You will get that 10 marks by choosing the correct formulae. If you are using the correct formulae from the data sheet, then you will get marks for taking a correct formula, choosing the correct formula. You are getting marks for correct substitution into the correct formula that is in the data sheet at the end of your question paper. Then we advise and encourage learners to use their calculators. Make use of your calculator and make sure that when you go to the exam room, you use a calculator that you know how to use, the calculator that you are familiar with. So learners must be able to use the calculator. Don't crack your skull thinking about the addition of numbers, multiplication of numbers. No, just punch your numbers in the calculator. Even if it's 1 plus 1 and you forget it's 2, don't take much to think. Just say 1 plus 1 using your calculator. And your calculator as a learner must always be in a degree mode. Okay. The third topic is trigonometry. The third topic is trigonometry. In trigonometry, which weighs about 50 marks out of 150. 50 marks is under trigonometry. Learners are expected to come up or obtain a minimum of 15 marks from this topic in paper 2. How are you going to get it? How are you going to make sure that your learners, as a teacher, how are you going to make sure that the learners will be able to get this minimum of 15 marks? They will get that by using the correct formulae from the data sheet and the correct substitution. The last topic is Euclidean geometry. Euclidean geometry, which weighs about 40 marks. Euclidean geometry, we said that learners must come up with a minimum of 10 marks. And learners, we encourage you to be able to revise. Encourage you to revise the proofs of theorems that are examinable. If a proof of theorem is there in your question paper, it has a minimum of 5 marks, the proof. So you can get that 10 marks in Euclidean geometry by being able to do the proofs of theorems. So by doing that proof of theorems, then being able to prove the theorems, then you will be able to get that minimum of 10 marks from the Euclidean geometry. So in this paper, under statistics, you get your 10 marks, and then you take your 10 marks again in analytical geometry. You can take your 10 marks in trigonometry, and then you take your 10 marks from Euclidean geometry. Then that gives you your 45 marks out of 150. 45 marks out of 150 then gives you 30%. And this 30% is then now considered as a pass. So you passed mathematics once you reach that 30%. Reach that 30% by making sure that you don't score less than 45 marks. Okay, now let's now continue with the slides. Right. In statistics, how to target marks in statistics? We said that in statistics you need to target a minimum of 10 marks. Right. There is question 1. In question 1, what are the key principles that teachers have to hammer? Get many examples as possible. We encourage this by saying don't use 1 or 2 past exam papers, but use as many as possible for more than 5 different papers so that learners will be familiar with the questioning styles that are being used. Okay. Under question 1.1, usually the question comes up saying that determine the mean or the standard deviation. Always those question colleagues or those questions learners, teachers, learners, those questions whereby you are required to determine the mean, the standard deviation. We said learners and teachers always use the calculator. We always encourage learners to use the calculator. Learners use the calculator. Don't crack your skull. Even if there are other methods that you can use to determine the standard deviation, the mean, please do not use any other method but stick to the calculator. Teachers, make sure that you teach learners, and these learners are able to use their calculators. And when you go to an exam room as a learner, make sure that the calculator that you will be using in the exam room is the calculator that you understand, is the calculator that you are using each and every day when you are practicing. Okay, so each and every learner must be having their own calculator. Scatterplot line of best fit. So learners must be able to do the scatterplot. Those are the free marks. Those marks you are just given. Please make sure that you score those marks. You must be able to determine the line of best fit, the least squares regression line, the correlation, determine the value of the correlation, and then after determining that value of the correlation, you must also be able to comment on the correlation in that particular question. So make sure that 1.1, question 1.1, those marks are yours. Those marks, you grab them. Those marks, you don't lose them. Okay. Central tendency, measures of central tendency and the measures of dispersion. Now, determining the mode, the median, the mode, mean, the mode, and the median. This is from grade 11. This is grade 11 work. So, learners must be able to determine the mean using their calculator. Understand and know the definition of a mode. A mode is that element in the data that frequently appears in the data. So the mode frequency is an element or is the member of that appears frequently or the most appearing element in the data. The median, how do you determine the median? And how do you find the median if there are two elements that are in the middle of the data? Okay. From grade 11, you were taught how to draw the 5-number summary, or how to pick up the 5-number summary from your data. From the data that you're given, make sure that the data must be your given data, make sure that it is in an ascending order. The data must always be in an ascending order. When we say the data is in an ascending order, we mean that the data is, the elements are arranged from the smallest element to the biggest element. So, if it is in that order, then we say that the order is in ascending order, or the order is ascending. The learners must determine the range, the upper, the highest element minus the smallest element, the interquartile ranges. Then if the learner is able to identify the 5-number summary, so the learner as well must be able to draw the box and whisker diagram. After drawing that box and whisker diagram, then are expected to be able to comment on the skewness. The learners must be able to comment on the skewness of the data. Learners must be able to comment whether it's positively skewed, symmetrically distributed, or skewed to the right, skewed to the left, positively skewed, or negatively skewed. So it's very, 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 very important. So those are the key principles and those are the key aspects where learners are expected to know and understand and can easily grab marks from those. Right, let's come now to the analytical geometry, where we say we are targeting a minimum of 10 marks. Under analytical geometry, we are targeting a minimum of 10 marks. Remember, learners, paper 2 mathematics, there are 2 questions there. The first one on analytical geometry is based on the grade 10 and 11 work. Your quadrilaterals, your triangles, distance, gradient, and the midpoints, as well as the angle of inclination. We said, start from grade 10. Learners must be able to determine the distance between any given points. So, to determine the distance between the given points, it's very important that you identify the points that you will be working with to determine that particular distance. Always use the formula. Copy the distance formula from your data sheet. You substitute into the correct formula using the brackets. Then the calculator, you use them to determine the values. Don't crack your skull. Don't use your brain. That use the calculator to add up or to figure out the final answers. Right. That is the distance between 2 points. Use the correct formula. Substitute, correct substitution, and then use calculator to determine the values. That's why they are saying that the calculator use is imperative. The gradient, we know in grade 10, the gradient was defined as the steepness of a line, or gradient is a slope. Determine the gradient of lines. There are aspects that you need to understand under the gradient. You must be able to determine the gradient between 2 points. You must be able to determine the gradient between 2 points. If points are given and you are required to determine the gradient, then you use the gradient formula that is given at the end of your question paper, which says that m is equal to y2 minus y1 is over x2 minus x1. Right. Parallel to each other. Now, you need now to understand what is happening in terms of the gradient. What is happening in terms of the gradient whereby 2 lines are said to be parallel to each other. So, if 2 lines are parallel, then what is happening? What about the gradient? What is happening about what can we comment on those lines in terms of the gradient? Learners, remember that from grade 10, having 2 lines parallel to each other, those lines are having the same gradient. The gradient of parallel lines is the same. Parallel lines have the same gradient. If line 1 is parallel to line 2, if line 1 is parallel to line 2, then therefore the gradient of line 1 is the same as the gradient of line 2. So, what I'm saying here is that line 1 parallel to line 2. Then therefore, the gradient of line 1 is equal to the gradient of line 2. So, parallel lines have the same gradient. Parallel lines have the same gradient. Is equal to line 2. All right. Perpendicular to each other. Perpendicular to each other. The 2 lines are perpendicular. So it means that when these lines, two lines intersect, they subtend an angle of 90 degrees. Then therefore, the gradient of line 1 multiplied by the gradient of line 2, then that gives us -1. It gives us -1. Gradient of line 1 multiplied by the gradient of line 2 gives us -1. So if gradient of one line is given, and then you are required to determine the gradient of another line, while also given that the 2 lines are perpendicular to each other, then therefore you will simply use this concept, that rule, that line 1, gradient of line 1 multiplied by the gradient of line 2 is equal to -1. Or else you can say the product of the gradients of lines that are perpendicular. If two lines are perpendicular, then the product of their gradients is -1. Product of their gradients is -1. Okay, that is distance, gradient. Let's move on. Midpoint. Midpoint. The coordinates of the midpoint. What is the midpoint? If you're given two lines, then the midpoint is that point that is in the middle of the other two of the two given lines. So, to determine the midpoint, we use the correct formula, correct substitution, making use of a bracket. The calculator is always imperative. It's important to have your calculator to punch your numbers to get the required figures. A point given in another point and the midpoint. In other times, there are questions whereby you will be required to determine the point that is at the end, while you are given the midpoint and then the other point that is on the other end. Then you'll be required to determine the coordinates of the point that is on the other end, while the midpoint is given. So teachers make sure that the learners are able to achieve that, and learners make sure that you revise as many questions as possible so that you are sure that these marks are yours. You lose these marks. 2.4. This is the concept that now was introduced. This one was introduced in grade 11. It was now introduced in grade 11. The concept of inclination. The concept of inclination. What is the inclination of the line? It is that angle that is subtended by the straight line above the x-axis. And that angle above the x-axis must be on the right-hand side. The angle on the right-hand side is subtended by a straight line. When cutting the x-axis, that angle is said to be the angle of inclination. Then when we determine that angle of inclination, we say theta is equal to arctan of the gradient. So for learners, for you to be able to determine the angle of inclination or the inclination of a line, you need to know the gradient of the affected straight line. Once having the gradient of that affected straight line, you will then now come and use this equation which is from your data sheet. At the end, you copy it correctly, then M is your gradient. You use that, but you copy it as it is from the data sheet. So that will help you to be able to practice, will help you to practice as many questions as possible so that whenever you are required to determine the inclination of a straight line, you will be able to determine the inclination of the straight line. Right. 2.5. Equation of a line. Equation of a straight line. We are talking about lines. These are the straight lines. Determining the equation of a line given 2 points through which the line passes. In order for you to be able to determine the equation of a straight line, is either you know the 2 points that lie on that particular straight line. then it will help you to determine the gradient and to determine the equation of that straight line. The gradient and the point. Number 2, bullet number 2, if you have bullet number 1, you can determine an equation of a straight line in the presence of 2 points given. Number 2, you can determine an equation of a straight line provided a gradient and a point of that straight line are given. 1 point and a gradient are given. You can also determine the equation of a straight line. Parallel to and perpendicular to. If you are required to determine an equation of a line which is parallel to another line, there is no need for you to determine the gradient of this straight line. You know that the parallel lines have the same gradient. So you take the gradient of another given line, provided that the two lines are parallel. Then you use it to determine the equation of the straight line, because it's parallel to another straight line of a given gradient. Then therefore you already have the gradient. Or perpendicular to a particular line, when also you may not be having the gradient of the affected straight line, but if this particular straight line is parallel to another straight line, you can easily get the equation by using that concept which says when two lines are perpendicular to each other, the product of their gradients is -1. Then therefore we use that concept to determine the gradient of the affected straight line. Then you proceed from that point and you find your equation. Two intercepts through which it passes. We are talking about the straight line. You can also easily determine the equation of a straight line in the case whereby you are given the y-intercept of that straight line and you are given the x-intercept of that particular straight line. Then from there you can easily determine the equation of a straight line. So there are 4 conditions. Condition number 1 is either you have 2 points that lie on the affected straight line. Option number 2 is either you are given or you know the gradient at 1 point, or else you know if this line is parallel to another line or this line is perpendicular to another line, and 1 point on this affected straight line is given also. Number 4 is either you are given the y-intercept and the x-intercept. That's why they are saying 2 intercepts through which it passes. Given the y-intercept and the x-intercept of a straight line, you can easily determine the equation of a straight line. Right. Now, as we are moving to grade 12 with analytical geometry, a circle now has been introduced in analytical geometry. Then, what is important now that learners should understand? Determine the equation of a circle. A circle can be having the coordinates at the center of the circle. Having the coordinates of the center at the center of the circle and a point on the circumference of the circle, then a learner will be able to determine an equation of a circle. Coordinates of a circle can be given in a standard equation of a circle. Then now, as it is put in brackets, that completing the square. Now, you can simply complete the square, as the teacher has shown you how to complete the square, so that you put your equation in such a way that you will be able to identify the coordinates of the center and the coordinates of the center and the length of the radius from the center to the circumference of the circle. So there are two things that are very important to be able, in order for you as a learner to be able to determine the equation of a circle. One, you must know the coordinates of the center of the circle. Number two, you need to know the length of the radius, which is the length from the center of the circle to the circumference of the circle. Then, or it's either you have the point on the circumference and you have a point at the center. You know the coordinates of the center, you know the coordinates of the point on the circumference, then you can simply determine the radius. In other cases, you may not be given the center of the circle, but you are given the diameter, the length of the diameter, of which we know that the length of the radius is half the length of the diameter. Okay? Or else you are given points on the circumference, and if you join those points, you draw a line, then that line will cut through the center, and now I'm having the diameter. So if they require you to determine the coordinates of the center, you can simply do that knowing that the center is the midpoint of the diameter. Then you use the midpoint approach or the midpoint formula to determine the coordinates of the midpoint. Then that midpoint is the center of the circle. After getting that, you can simply determine the radius of the circle, and the coordinates of the center you already have. Then you determine the equation of the circle. Right. The equation of the tangent. Right. We need now to be able to understand or to be able to define what is meant by the tangent to a circle. What is a tangent to the circle? A tangent is a straight line. A tangent is simply a straight line that cuts the circle at once. It is a line that cuts the circle at once at the circumference. If a straight line cuts the circle at once at the circumference of the circle, that straight line is said to be the tangent. What else do you need to know about the tangent? If you draw a radius, if you draw the radius from the center of the circle to a point of contact between the tangent and the circumference of this, or the tangent and the circle, that radius, if it is drawn to that particular point, then therefore that radius is perpendicular to the tangent. So radius is perpendicular to the tangent at the point of contact. So radius is perpendicular to the tangent, or tangent is perpendicular to the radius. Okay. That was analytical geometry. Now, let's move now to the next topic, number 3 of the second paper, or paper 2, mathematics. In this topic, which weighs about 50 marks out of 150, learners are encouraged to obtain a minimum of 15 marks. Learners are encouraged to come with a minimum of 15 marks out of 50. 50 is the weight of this topic in paper 2. Right. One of the key aspects that we need to look at in trigonometry is the reduction formulae. Let us know the reduction formulae. Simplifying the reduction formula, will be given expressions to simplify. Preferably avoiding staccato, or rather use the substitution of 1 or for theta to find out the sign of the trigonometric ratio. We'll talk about that in the videos that will be done in preparing you for the trial examination. Make sure you emphasize the importance of the first writing in the trigonometric ratio, the trigonometric ratio for 180 and 360 degrees, or a core ratio of 90 degrees and 270 degrees, before writing the sign through the substitution by 1 for theta. So let's make sure that we can identify the quadrants in the Cartesian plane by using 360, 180 degrees, 90 degrees, and 270. Right. Compound angle identities. This is the new concept. There's this one, compound angle identities. Compound angles. Now in grade 12, the concept of compound angle identities has been introduced, which at a later stage, let us discover that there are double angles. But we first start from the compound angle identities. When angles are said to be compound, it means those are the different angles that sum up to a single angle. Now, how do we deal with such angles? We have the sine angle, compound angles, and the cosine compound angle formula, and the sine compound angle formulae. So those formulas, you find them at the end of your question paper. Make sure that you copy the formulas correctly. You copy the formulas correctly and use correct substitution into the correct formulae. All these compound angle formulae for cosine and sine are there in your question paper, in the data sheet at the back of your question paper. We emphasize that you copy them correctly, you substitute into the correct formulae. Those are the marks that you are expected to obtain. There are questions. In order for you to be able to solve them, you need to make the use of diagrams and the ratios or the ratios of angles, whereby you need to draw diagrams in the Cartesian plane. So teachers, make sure that your learners are having rulers and pencils, and give them as many questions as possible so that they do revise. They do revise and practice on how to solve such questions, whereby you don't have to use formulas, but you have to use the diagrams. These diagrams are accompanied by the trig ratios. Trig ratios, we talk of sine, cos, and tangent. So when using those diagrams to find solutions and ratios, make sure that you are using trig ratios of sine, cosine, and the tangent. Right, special angles. As from grade 10, when the trigonometry was introduced to you learners, you were told that there are angles that are considered as the special angles: 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. Those are considered as the special angles. But now, learners and teachers, for the learners that we are pushing to a minimum of 45 marks, which is 30%, for them, we are not encouraging them to memorize the values of the special angles. But they need to use their calculators. They need to master the use of their calculators. They must punch these values in their calculators and substitute them correctly. The proofs requiring the use of identities. In the case where the proofs, then the learners must be able to prove trig graphs, trigonometric functions. We use that most of the time. We say they are the trigonometric functions. Trig functions, trig graphs. Learners must be able to determine the period, the amplitudes, parameters of cosine, sine, and tan functions or graphs. Learners must be able to draw these graphs. Not only to draw, but determining the amplitude, the period. Even if the graph is given, then the learners must be able to analyze, must be able to analyze the diagram, analyze the function, and be able to answer the questions that will be based on the graph that has been plotted already. Plotting cosine, sine, and tan graphs is very important, learners. If you're given this question and has 5 marks, make sure that these 5 marks is yours. Don't lose these marks. If you are required to plot a graph for cosine or a sine or a tan, a graph sheet will always be given. The graph sheet will always be given. Then use that graph sheet to plot. Teachers, when revising with the learners, please provide the diagram sheets so that the learners will be familiar, will be used in drawing these graphs. Will know how to draw, how to sketch, how to plot. It's very important. So please, teachers, make sure that you avail the diagram sheets so that learners will be familiar in drawing these graphs. Okay. There are 4 topics in Euclidean geometry. There are 4 topics in Euclidean geometry. The last topic is Euclid in paper 2, then the last topic is in Euclidean geometry. This weighs about 40 marks. And we said learners target a minimum of 10 marks. Because we don't want anyone to fail, but everyone must achieve more than 45 marks. So that becomes 30% and above. Right. In Euclidean geometry, which weighs 40 marks, then we only want 10 marks, a minimum of that. The proofs of theorems, all grade 11 theorems must be known. Grade 11 learners, the grade 11 theorems must be known by learners. And check amongst those theorems, which of them are examinable? Which of them are examinable? And make sure that you revise, you study, you revise. Which of them are examinable and how to prove them? Prove those theorems. Proportionality theorem proof must be known. That proportionality theorem is from grade 11. It's from not grade 11, it's from grade 10. Applications of the grade 11 theorems, proportionality and similarity. So, in grade 12, the similarity that we studied in grade 10, we are still doing that. But now, a circle is involved in that similarity and proportionality that we dealt with as early as from grade 9 and grade 10. But now in grade 12, a circle is involved in that similarity and proportionality. The proof of similar triangles. You must be able to prove if two triangles are similar. Get those marks, learners. Get those marks. Make sure those marks are yours. Don't get less than 10 marks in Euclidean geometry. Don't get less than 10 marks in Euclidean geometry. Make sure you score marks. You practice. Make use of your previous question papers. Get as many questions as possible. Make sure that you follow your teacher. You ask for questions. You practice. This is the end of our paper 2 revision stride. Thank you very much. I wish you all the best.